Hi again. So let's now discuss all of the various ways we can use functions inside the functions, inside other functions. So basically, you have already seen that that you can use function inside other functions. You have already seen also that you can use the function you are defining inside it, then it's called recursion. But there are two other ways which you can in which you can use a function inside other function. And one of them is you can actually return a function as a result of some function. And second is you can also pass a function as an argument to a function. And in this video, we will have a look at these two options. So let's talk about the first one first. How you can return a function as a result of some other function. Why would you need that? The more advanced programs you create, sometimes you want to offer to a user not a specific result, but a function for him to use later on. So for instance, we will of course give a simple example here, but for instance, I don't know, you want a user to for instance, imagine you are creating a game and you want a user to get a tool which can do multiple things. Then this tool, you may think about this tool as a function which, depending on what user does with it, does different things. So as a result of some action of this user of this game, you want to return a different function to this user, and this would be a different tool for him. We will take a look at a much simpler example, an artificial one, where we define a function called math operation, which takes an argument as a name. So we input the name of math operation we would like to have, and this function will return, give us as a result a function which performs this operation. And for simplicity reasons, we assume that this operation, which will be returned, will just take two arguments. But we could write it in a more complicated way. There's no problem with that. You already know all the tools which are necessary to do it. You could write it with arbitrary number of positional arguments, keyword arguments, and so on and so on. We just don't want to make these things complicated. So how it works? Let's jump into Visual Studio Code. It works exactly like before. So we can use conditional statements to discover, to determine what operation time was included as an argument by the user, and then depending on what is what this argument is. So for instance, if the user specified that he wants to have sum as a result, we create and define function inside our function. So as you can see, we do it in exactly the same way as we did previously. As we did normally in scripts, we were defining functions. Here we simply do it inside a function. So when we use indenting, we start at this level because we were already in an if statement, and we create a function like this. And this function is called f. And similarly, like with variables, this name exists only inside the body of the function. If I, for instance, let's remove this code for now. If I try to use function f here inside the script and try to run it, Python, sorry, this is not the script, Python 3, let's clear the terminal first, Python 3 math operation. .py. So if I try to run this example, Python tells me that name f is not defined. Why is that so? This is the same reason we discussed at the beginning of this chapter about advanced functions. This function, this f function, exists only inside the function. Now I am trying to call function f outside of the function. It doesn't exist here. Python doesn't know what it is, so he doesn't know what to do. If we want to get the desired function, we can get it as a result of a call to our math operation function. So let's say we want to have sum, then I input the argument sum, and then Python executes code which is inside the function math operation. My argument is equal to sum, so Python defines a function f and defines it in this way, so the result of function f should be a plus b. Python skips all of this code and then returns the function f it has defined here. So this function is returned as a result of this function, and then we store it in a variable s. So what is inside our variable s right now? Well, it's a function. So we can use it as we would use a function. So we could take this function which is stored in variable s and use it with 2 arguments, because we know that this function takes 2 arguments. And now if I try to run this code, this script, I will get the answer 13. So as you can see, 2 was added to 11, so I got the desired sum. If I want to get multiplication, I can change the argument here, and now the result of this function will be this definition of a function. This function defined here. This is stored as a result. This is returned as a result here. This is stored in my variable s, and now if I run this script, I will get the answer 22. So this is how you return a function as a result of calling some other function. And so this is this first thing you can do with functions. You can return them as a result of a function. And there is also another thing you can do with functions, namely you can return functions as you can take functions as arguments. So how do you do this? Let's say let's go to the example in the Visual Studio Code. Let's say we have created 2 functions, like a function add, which adds 2 numbers, and a function multiply, like here. If we want to have a general version of operation to perform, so basically we can see that both these functions have similar structure. They both take 2 arguments. They both execute some operation on these arguments. They just differ what the final result is. We can create a more general form of a function, more general structure like this here, and then pass this function or this function as an argument to this perform function, and then use it inside exactly the same as we would use, for instance, exactly the same as we were using print functions. So when we had built-in functions, we were using them just like this. If we assume that this argument is a function, we can also use it inside the function exactly in the same way. We just assume that this name here is a function, we write this name, and then use brackets to provide arguments into this function. Okay? And here we can see that if I use perform with add a function as an argument for the operation parameter, I will get the sum, so 7 plus 8, so 15. and if I perform multiply, I should get multiplication, so 7 times 8, so 56. Let's check if this is the case. Let's write Python 3 math operation helper. And yeah, we get the correct result. So we get 15 for sum and 56 for 56 for multiplication. Why would you need something like this? Well, sometimes you want to have generalized versions of a function because you don't want to repeat yourself. So for instance, imagine that you are writing an application where after some set of steps, user performs an operation, but you don't know by default what this operation will be. It will be determined along the steps of the user. Then you can use a general version of a function and just input the final operation which should be performed as an argument. So in this way you can write a simple short portion of code, and your user along the steps will input necessary information to perform to decide what operation to perform. Okay, so this actually concludes our notebook about advanced functions. As you can see, things now get much more complicated than in the introduction course. We learn about various ways of doing things. We often try to do things in different manner to get the same result. I understand that there is a lot of knowledge to learn and to get a feeling about this. Hopefully you will get a much better understanding of these topics after you solve exercises which are here at the end of our chapter. I wish you good luck with these exercises. Don't forget to submit them if you are subscribed to the course. And yeah, that's all. And see you in the next chapter. And thank you for your attention in this one.